Everybody, welcome back to Miss Johnson's Learning Kitchen. Miss Johnson's Learning Kitchen, where we learn about things like ceramic pigs, and where we learn about things like science, where we learn about things like the chemical potential energy in a plum. Miss Johnson's Learning Kitchen. All right, welcome back. So, we, in our last video, or maybe in the next video, depending on which order you watch these in, talked about conduction. Right now, it is time to talk about convection. So, just like I told you, we have a catchphrase. The one for conduction is ouch, don't touch, because it requires direct contact of molecules, and that means if you touch it, you can get burned. Heat transfer through convection, we're going to think it's like a yoga mantra. Heating up, cooling down, and we'll get to that in a little bit. So what is convection? Convection is a way of heat transfer that works only in fluids. Fluids being things like air and water, liquids. So when we're talking about convection, we're going to talk about how heat moves through those things. As those things get warmer, their molecules become less dense. In a cooler state, the molecules are closer together. As they get warmer, they spread apart and they begin to rise. As things heat, they move upward, and as they cool, they move downward. And what winds up happening is this forms what we call a convection current, where things are moving in a non-stop circle, getting close to a heat source, warming up, getting away from the heat source, cooling down, becoming more dense and sinking. And that will just keep going on. We're going to see a couple of examples of that. Okay, so in our first example, we're going to look at what happens when water boils. Sorry, my cat makes it seem like a good idea. We're going to look at what happens when water is introduced to a heat source at the bottom. And the water inside, at the very bottom, starts to build up heat. And as it builds up heat, it becomes less dense. As it becomes less dense, it eventually evaporates and turns into gas bubbles. We will see those bubbles of gas rise through the water and come up as steam. We will see that hot water rise to the top, and the air that is heated above it also begin to rise. As the water bubbles at the top, and it hits the top here, the air outside is cooler than the heat source at the bottom. The water will cool and kind of sink back toward the bottom, where it will start heating again and again. This is what we call a rolling boil. So the first thing we need to do is introduce heat. And this time we're going to go all the way to high. All right, let's hope sincerely that this does not break my bowl. Okay, so while we're waiting on this to actually boil, I have a little bit of a color fragment behind this water, and you can already see by looking right around here and right here where this color is, you can see the water start to rise as it heats. If I touch down here, the water is warming up, and you can see that upward movement. This is convection happening. As we see the water and we see it continually getting hotter, you'll notice that this upward movement is getting faster and faster. On the other side, over here, you can actually see patterns looking from the top of downward movement happening, and that is that convection current happening. Our warm air is going up, and as it cools around these edges and the surface, we see it start to come back in here. We see an inward flow coming down from the top. So we'll just observe this for a minute. As they say, a watched pot never boils. So we'll come back to it in a few and see how that convection is progressing. You can already start to see some little bubbles starting to form. This is the water becoming hot enough to evaporate at the bottom and release as water vapor. Okay, it's been about 2 more minutes, and at this point we can really see that convection pattern going. We can really see the upward momentum, the upward movement of the water here. We see more and more bubbles going, and then again around the edges where it's cooling, we see the cooler water start to sink back in, and you see sort of a circular movement forming this way and this way. That's what we call a convection current, where it is ongoing. You can also tell that the heat is rising off the top because of the fact that we have steam starting to coat and condense there and rise off of the pot. We'll check back in another couple of minutes. So this is giving you a little bit of an alternate view. This is kind of the view I have. And looking into the pot, it does sort of look like I've summoned the Eye of Sauron or something. But it's just a refraction of the things on the other side of the pot. But you can very clearly see, again, that convection pattern where we have it rising upward. We see the upward movement of water here, and then coming in, you can see where it's moving down as it cools and forming that circular pattern. You also are seeing a lot more bubbles kind of hit toward the surface. So I'm going to show you overhead what this is looking like right now. So you can't see as much of the actual water movement as you can from the side, but what you can see is that the bottom of the water down next to the heat source is evaporating and is becoming less dense. And as it becomes hotter, it is rising. We see it rising in the form of steam. And again, when we look at it from the side, we see it rising in the pot in that particular kind of color pattern. Okay, as we're getting closer and closer to a full boil, you see more and more bubbles going to the top. And now you can really see that upward movement. Again, don't forget to look for the cooler water that's hitting the surface. Where it's cooling off, it starts to sink back down. If you watch through this area, you see the downward movement. And this is just really, it's a glass bowl with boiling water, and it looks this cool. This is convection in action. This happens in the air all around us all the time. Hot air rising and cool air falling is responsible for our weather systems. This happens in the ocean, where we see warm water rise to the surface and cold air sink, also responsible for a lot of weather and climate patterns on Earth. And we'll check back in another few minutes when we've hit our actual full boil. I just thought it looked really cool right now, and I wanted to talk to you guys about it. Okay, I know I keep saying that I'm gonna wait till we're at a full boil, but then it just keeps looking cooler and cooler. I guess it keeps looking warmer and warmer. We're really starting to get close to that boiling point now. You can see all of the steam rising off as this water becomes less dense and turns into water vapor. You can see more and more bubbles coming, and again, here is convection happening. It is so pronounced through here. It looks like an aquarium of doom. You see this just big movement of water upward as it heats, and around the edges you see that downward movement as the cooled water sinks back in to take its place, and it goes in this non-stop heating up, cooling down, heating up, cooling down sort of movement. So remember, guys, it's like that weird sort of, it sounds like we're doing some sort of weird yoga. Heating up, cooling down. Heating up, cooling down. Heating up, cooling down. I think I'm stuck. Oh no. I better get help. Oof. Well, Miss Johnson's learning kitchen. It's so messy, but it's fun. Full of dangerous things that burn her to teach science to young ones. Miss Johnson's learning kitchen, where she never forgets that she's recording while she's singing a little song about water that is boiling. Oh, I'm recording. Okay. Please ignore that song about my learning kitchen. It is messy and dangerous, but apparently more musical than I thought. All right, at this point, we are at a full boil. It will only get more boily from here. So, looking at this is pure convection in action. We'll see a couple of other places where it happens throughout the house, but you see these rapidly moving big bubbles here. This is water turning to gas, turning to water vapor and rising. You see it just rising to the top very rapidly. You can see lots of smaller bubbles doing the same. And then if you look around the top, you see that water that starts to curve back down. Why? It is losing a ton of heat to the air right here. This water is over 200 degrees Fahrenheit. The air above it is probably about 75 degrees Fahrenheit. So that's a lot of heat lost. And as it cools very rapidly, it goes straight back to the bottom. So again, we're in that heating up, cooling down, heating up, cooling down. Heating up, cooling down. Heating up, cooling down, heating up, cooling down, heating up. You'll never forget this because it's so annoying. Cooling down, heating up, cooling down. Okay, so we've been looking at the boiling from the side view. We've been able to really see the convection patterns again. It seems like the aquarium of doom. Looking at it with just a white background, you see that air escaping, you see that water moving upward, coming back on the sides, moving upward, coming back on the sides. That is a convection current. What it looks like from the top, boiling water, but we see it rising. We see the heating up, the cooling down. And while the eye is still on, I want to point out that though our water has heated, this eye is still producing a lot of heat. This we talked about as being, conduction that heats the eye. And then the fact that we can feel the heat coming off of it means that it does have radiant heat as well. But one other way you can always test to see if convection is happening, what's happening to the air above this, the air is warming and rising. One way we can test this is taking a piece of paper. We have a piece of paper that's just kind of at this point hanging down as it normally would, but if we get it up and over the heat where the air is rising, you'll see that it will actually push the paper up. In some instances, I've done this and been able to let the paper hover, but I don't want to burn my house down on camera. So for now, we'll just see how that's working. It's just the warmth of the air moving upward that is pushing this piece of paper. Another popular place that you'll see convection used in your home is air conditioning vents and heat vents. In my house, and I'm just in the downstairs kitchen area now, in my house, all of my air conditioning vents are in the ceiling, and this is because they know that cooling down thing happens and that the air will sink if it is cooler. So the cooler air sinks and all of my heating registers are in the floor because that warm air will rise. And a last note about convection. We see it all around whenever we see wind blowing and whenever we see clouds forming. We know that these things are tied into the water cycle. And guess what? That requires an uneven heating of the Earth's surface. For example, the driveway will get hotter than the grass. And when that happens, it causes moisture to rise into the air. When that moisture and warm air rises, we see the formation of clouds. Normally you could see a mountain range over there, but we've had a lot of convection happening and clouds forming. You can see the wind moving my flag or my herb garden here. All of these actions are caused by global convection currents, which we will get into later. So I want you to remember this as I'm standing out in the blazing humid sun and it's just horrid. I want you to remember that winds and clouds, our climate and our weather are caused largely by convection. And guys, remember, Convection comes down to heating up, cooling down, heating up, cooling down, heating up, cooling down, heating up, cooling down. Thanks for watching. Say bye-bye. 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 We tried.